Assalamualaikum class. This is my first lecture of first year and the topic is freezing point depression. Freezing point depression. As you know, freezing when occurs? When liquid converts to solid. It means that we freeze the liquid and it converts to solid. As we know, a solution is formed by combination of solvent and solute. When a solution is formed when solvent is combined with solute. You know that solvent has greater ability to evaporate. The solvent has the greater ability to evaporate. But when we add a non-volatile solute, in the solvent, it decreases or lowers the vapor pressure. Now when we talk about the relationship of vapor pressure, boiling point and freezing point. The solvent has a greater vapor pressure. It has lower boiling point and greater freezing point. When the vapor pressure of solvent is greater, it means the temperature gets lower. Boiling point low. And it will start freezing. When temperature will low, boiling point low, and the substance will get freeze. So it has high freezing point. This is the case for solvent. Now when we talk about solution. Why we are not talking about solute? Because solute is not involved in vapor pressure. Solute lower the vapor pressure of solvent. So we are generally talking about the solution. In solution, as we know, vapor pressure decrease because it involves solute. Solute lowers the vapor pressure. Vapor pressure gets low. Boiling point gets high. And the freezing points get low as well. So in general, the solvent has greater freezing point and solution has lower freezing point. This is because of vapor pressure. Vapor pressure low, freezing point low. Now we draw the graph. I will elaborate it with the help of a graph. In vertical axis, I am taking vapor pressure. At horizontal axis, I am taking temperature. For the vapor pressure of pure solvent, I am denoting it with P naught. And with partial vapor pressure, I am denoting it with P. In the previous lecture, you have learned about boiling point. The curves in the elevation of boiling point move forward. This is because temperature gets increased. While in depression of freezing point, the curve will move backward because temperature is decreasing and the solvent is going to form solid. Solvent converts to solid. This is actually the case. Now look at this. This is the curve AB. This is for pure solvent. For pure solvent. The curve shows that vapor pressure of pure solvent is increased. Vapor pressure of pure solvent is increased. It means it has greater freezing point. Look at this curve, DE. This is for solution. So for solution, the curve shows decrease in temperature. So vapor pressure decrease because it occurs in low form. It is in low form. Vapor pressure decrease. Vapor pressure decrease. Then freezing point also decrease. What is this? BC. This is actually the sublimation curve. Sublimation curve. The sublimation is a process in which solid convert to gas directly without being converted into the liquid. So here solvent convert to solid. This curve AB shows increase in freezing point. When the solvent starts freezing and converts to solid form, this point B shows that at temperature T1. This is temperature T1. At temperature T1, the solvent starts freezing in case of solvent. And the solution starts freezing at the point of E. And I am denoting this as T2. This is the freezing point of solution. This is the freezing point of solvent. I am denoting it as del TF. That is change in freezing point temperature. Change in freezing point temperature. B is a point where solvent freezes at temperature T1. E is a point where solution freezes at temperature T2. So I can write it as del TF is equal to T1 minus T2. This is T1, this is higher value. Now we are going with the, in order to decrease, the temperature is getting decreased. So higher value is T1 and the lower value is T2. The temperature is changed from T1 to T2. So I am writing it as T1 minus T2. Now there is another term called as molality. Molality is denoted by small m. The formula for molality is number of moles of solute divided by number of kg of solute. Number of moles of solute by number of kg of solute. We can write it as you know, number of moles of solute are equal to mass in gram divided by molar mass. Mass in gram of solute divided by molar mass of solute multiplied. As this is in denominator, I am writing it as 1 by number of kg of solvent. This was a denominator. So I wrote it as 1 by number of kg of solvent. But I need the value of solvent in kg. This is telling me in grams. Convert grams into kg. Thousand. I will multiply it with 1000 in order to convert gram into kilogram. So this can be 1000 divided by number of kg of solvent. I can denote mass in gram as W, and this is mass in gram of solute. For solute I am using suffix 2. Molar mass of solute. For molar mass I am denoting it as M, and the suffix is 2. Multiply 1000 divided by number of kg of solvent. For kg I am denoting it as W, and for solvent I am using suffix 1. This is all about molality. So now the change in freezing point temperature is directly proportional to molality. When we convert proportionality to equality, it will become Kf into M. M is for molality, Kf is for cryoscopic constant or freezing point elevation constant. Cryoscopic constant. When the value of molality is unity, that is when molality is equal to 1. When molality is unity, del Tf become converted, or del Tf is equal to Kf. They both have the same value in case molality is equal to 1. This is cryoscopic constant.